With the algebraic method, the first step that we need to do is we need to separate the terms by letters. For example, this first term that I see here, all the term, I will call it A. Okay, I will call it A. The second, I will call it B. The third one, I will call it C. That's just very casual that it happens that C is equal C in this case, but it's not all the time like this. The other terms in the other side of the reaction will be D, E, and F respectively. This is the first thing that we need to do. Second part is we're going to list the elements just like we do at all times when we try to balance. First, we're going to write the metals, okay, then the non-metals, and then hydrogen and oxygen. Hydrogen is not part of this reaction, so just oxygen will be enough. Okay? So once that you have listed all the elements, we're going to write some equations. You will see how this works. For example, calcium is located in my term A, okay? And I have three calciums A, okay? I have three calciums in A. So what I'm going to say is that I have three calciums located in the position A. I have no calcium located at B nor in C, okay? Now, the arrow will be completely replaced by the equal symbol over here, and then tell me, how many calciums do you find in letter D?
One.
One calcium, okay? So you have only one calcium that is located in the position D, and we have no more calciums, so this first equation is going to be 3A equals 1D. Remember that 1 as a coefficient can be totally ignored, so you can also say that 3A is equals to D. Okay, so this is going to be my first equation. I'm going to do the same for silicon. Okay, what will be the equation for silicon? How many silicons I have located in B? How many silicons in B?
One.
One.
One silicon located in B. And how many I have in the other side?
One.
One that is located in the position D. Okay, so as I told you, 1 as a coefficient can be totally ignored because it is invisible. Now, phosphorus. How many phosphorus I have located in the reactants?
Two.
I have two phosphorus. Where do I find this phosphorus? In A, B, or C?
In A.
2A. I have any other phosphorus in the reactants, so I write the equal symbol. And how many phosphorus and where I have in the products?
We have one in F.
One located in the position F, and one can be invisible, okay? So you can totally ignore one over there. Now, carbons. How many carbons I have in the reactants and how many?
One C.
One C. In the products, I have how many?
One E.
One E. And here again, because 1 is invisible as a coefficient, I can totally ignore it. Now oxygen, that's why we leave oxygen in the very last step, because you will see that oxygen is, the equation for oxygen is the one that is going to be more complex. So how many oxygens I have in the reactants?
Miss, it's not 8A and 2B
8A, 8, 8A, and
plus 2B,
plus 2B. And in the products, I have how much?
3D plus 1E.
3D plus 1E. And 1 as a coefficient can be totally ignored. So this, what we have over here, are, as you can see, those are equations, okay? And because these are equations, we're going to work like we used to work in math. Now, the second step is this one. The third step is we're going to see what variable, what letter is repeated the most amount of times. Let's see. The letter A is repeated in here, here, and here. Letter A, as you can see, is 3 times. Now let's analyze the letter B. Letter B is here and here. Letter B is only 2 times. Letter C is only here, nothing more. Yes. Letter D is in here and also here and also here. Letter E is here and there, and F, as you can see, is there, only once. I'm going to choose another color. This one. Okay, so what letters or letter is repeated the most amount of times?
A and D.
Repeated the most number of times is letter B, and also, no, letter B, no. Which one do you say, sorry?
It's A and D.
A and D, yes, A and D. So, we're going to choose which one we're going to be working on. Now, me, Martinez, I usually work with the one variable repeated the most, that is in the left side. The reason is, for example, when I do mathematical equations, I used to work with my variable located in the left, okay? Like for example, x equals, I don't know, 3x plus 4, for example. I usually take all my variables in the left. That's my personal choice. And because I like to work like that, I'm going to choose the variable a because it is located in the left. Also, if it's already in the left, it is easier to isolate. Okay? So, you can choose which one do you want to work. Now, another way to analyze is try to see the one that is simpler. You can either choose A or D, it doesn't matter, okay? It doesn't matter. If you want me to do it within the 2 ways, I can do it for you, okay? It's okay. Now, me, Martinez, because of my OCD, I always work with the one in the left. Now, in this exercise, it's easier to work with D. Ahora, le voy a explicar por qué es más fácil trabajar con D en vez de A. All my A's have coefficients. Todos mis A's traen coeficiente. But, as you can see, D, this D is alone, has no coefficient. This one also has no coefficient. So it is easier to work with D. Now you can choose A or D. It doesn't matter. Which one do you want me to choose? A or D?
D.
D. It's okay. I'm not going to work comfortable, but yes, D is the easiest. You can also try with A and it's going to give you the same answer. So this is what we're going to do. You will assign any value to D. Okay? We will say that D is equal to any number. Now, I personally choose 2. And why 2? Because when I am balancing equations, the first number that I use to start balancing is always 2. O sea, cuando yo balanceo por tanteo, siempre comienzo dándole un valor de 2 a alguno de los términos. So that's why I always begin with 2. Now, my students from section 2, they say that they want to start with 1. Está bien, but sometimes working with 1 is going to cause that you have to use a lot of fractions in all the, well, not in all, but in many. Ay, qué molestas. You have to, if you use the value of 1, sometimes you have to use fractions. And I know that you kind of don't like fractions, so I totally recommend to use 2, okay? I totally recommend to use 2 as a number. It can be any number. If you say, no, miss, I feel better to work with 10, you can use 10. But in the end, remember that we always need to simplify the reactions. So try to choose smaller numbers, okay? 1, 2, 3, 4, 5. More than that, I think will be very difficult. But choosing 2, for me, it's okay. So we're going to start by assigning the value of 2 right here, okay? And from this value, I will obtain the other letters. So I'm going to call, I'm going to start writing all my equations. Okay, so my first equation, from all the equations that involve D, which one is the simplest? The simplest. 1, 2, or 3? Which one is the simplest equation to start working with D?
2, miss.
The number 2, because it's just an equality. It says that B is equal D. Remember, we assign a value to D, which is 2. So we say that B is going to be equal to 2. And with this, we find another value. So I'm going to start writing my letters here beside. I will write A, B, C, D, E, and F.
Miss, I have a question.
Uh-huh.
Um, I didn't hear why you place to D the value 2. Why you place 2? Like it will be the value
You
of
have
D.
to choose a number. You have to choose a number. The number could be any number. A number you feel comfortable with. I know it sounds weird because it's not a person, but a number that is easy to work with. And easy to just imagine the mathematical tables of multiplication. The easiest ones are multiplication of 1, 2, 5, and 10. Okay? But as I told you, it is better if we work with small numbers. So starting with 2 is a good way to start. You can also work with 1. 1 seems to be the easiest, but sometimes working with value of 1 is going to make you use a lot of fractions, and that's something I don't want because you don't like to work with fractions, but in the end it is the same. Okay, so I personally choose 2. That's always my first choice. You can use 1, it doesn't matter. Okay, but Choosing 2 is a nice choice. You can try with any other number. In the end, the answer will be the same. So I tried with 2, and as you said, the easiest equation to work with is the number 2. So I already used this equation. Now I know two values, the value of D and B, okay? I know that B is 2 and that D is also 2. So I have to find the rest of the values, A, C, E, F. Now what other equation is easy to work with, 1 or 3?
1.
We have 3A equals D. You already know what is the value of D, okay? So you have 3A equals 2, okay? We know that D is 2. So right now we're going to isolate A, and to do that, to get rid of the 3, I will divide by 3 the two sides of the equation. So this is going to give me A equals 2/3. I know, miss. With fractions already. Yes, with fractions already. But it's okay. You will see that it's not too complex. Now we found the value of A, which is 2/3. Okay, so we continue working. Now, take a look. Now we know A, B, and D. What equation in this moment is easier to work with? I already used the first and the second equation. I already know A, B, and D. Take a look. I will number again my equations. 1, 2, 3. Okay. Take a look. If I use the third equation, okay, if I use the third equation, I know A, I know B, okay, I know D. So I can easily get E. If I use the second equation, I don't know C and I don't know E. Okay, I don't know neither of them. So I cannot use the second equation yet. In the first equation, I know A, which means that I can easily get F. So which one do you want me to do first, 1 or 3? It's okay, we can do 1 or 3, doesn't matter in this case. No importa porque tenemos la misma cantidad de incógnitas. Here, one unknown, and here also one unknown. Entonces, no importa, okay? I'm going to start with 3. So it says 8A plus 2B equals 3D plus E. Okay? I know the value of A, which is 2/3. I know the value of B, that is 2. I know the value of D, that is 2. And I don't know what D is. So here I have 16/3 plus 4 equals 6 plus E. And now to isolate E, I will subtract 6 in each side of the reaction, of the equation, sorry. So this will allow me to cancel 6 with 6. So now my E is alone. And how much I get from this? I got 10 over 3. Did you get the same result as me? Did you get the same result as me?
Yes.
Okay, so with this, we found already the value of E. So E is equal to 10 over 3. Now I just need to find C and F, okay? This equation, I already used it. Now what equation can we, here you can either choose whatever, okay? We're going to finish with the rest of the equations. The number 2 seems easier. It says that C is equal to E. So C is going to be equal to the value that we obtain in E, which is 10 over 3. So C is 10 over 3. And to find F, I will use the remaining equation, which is 2A equals F. 2A equals F. You know the value of A, that is 2/3. So 4 over 3 is equal to F. And with this, we found the value of F, which is 4/3. And take a look. With this, we finished. But as you can see, the values that we got, they are fractions. Okay? So what happens when you have fractions or decimal as coefficients? What happens when you have decimals or fractions as coefficients? So imagine I have the values over there. I have 2/3, I have whatever, okay? So that means that those are my coefficients. I have 2/3 over here, I have 2, I have 10/3. What happens? That equation looks weird because I have fractions. I cannot leave my answers in fractions. They always need to be whole numbers. Now, remember this procedure. Remember this procedure that we do to turn fractions into whole numbers. If you have a fraction of if you have a fraction of 3 over 5, to turn it into a whole number, you have to multiply times the denominator. So this will allow you to cancel 5, and the whole number will be 3. So if you want to turn this fraction into a whole number, by what number I had to multiply? By what number I had to multiply? If you multiply times 8, it's going to give you 2, okay? Also, but if you multiply times 4, it's going to give you 1, which is also another whole number, okay? But that's not the point. The point that I want you to see is how you turn fractions into whole numbers. You always multiply times the denominator. So a fraction of 1/2, to turn it into a decimal, you will have to multiply times 2. Okay, the whole number will be 1. If you have a fraction of 3 over 7, by what number you have to multiply?
7.
Times 7. So 7 and 7 will be cancelled, and the whole number will be the number above. Okay, it's gonna be just 3. So knowing this, you're going to apply the same idea in here. How do you turn those fractions into a whole number? By what number do you have to multiply? By what number do you have to multiply?
By 3.
By 3, okay? But remember, it's a chemical equation, so whatever you do in one side must be doing the second side. So, in other words, you will multiply all the numbers by the same number 3, okay? So by 3, all of them. Okay, so these are going to be cancel, 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 and cancel. And here it's going to be equals to 2, 6, 10, 6, 10, and 4. Now, these numbers over here, they are whole numbers. This is good. This is good. You can use whole numbers as coefficients. But sometimes all of them are divisible by a number. Take a look. These are the numbers that we got. But all of them are divisible by what number? By what number are all of them divisible?
By 2.
By 2. And because they are divisible by 2, we are going to simplify the equation. You're going to simplify the numbers. You're going to divide all of them by 2. So 2 is going to turn 1, 6 is going to turn 3, 10 is going to be 5, 6 is going to be 3, 10 is going to be 5, 4 is going to be 2. And now, in this case, we say that these are going to be our coefficients. Already simplified. And all that is left is to write them in the same order here in the reaction. 1, 3, 5, 3, 5, 2. Remember that 1 as a coefficient can be ignored. But in this case, I'm going to leave it there for you to see that 1 is coming from this one from here. So what happens if you choose a different number for D? I choose 2, and you saw that I had to divide by 2, but sometimes I need to multiply this number. So it doesn't matter what really, what is really is the value that you assign to this letter. The only thing that matters is that all the procedure that you do here, the algebraic procedure, is well